Okay guys, this is the last one. It's L26, and for this one, I'm using the same chart that I linked for L25. I'll link it again here. I believe, yes, I think it's the same one. Regardless, if I haven't, I'll link it below in the description. And that's basically what I'm going to use. So for this one, we don't have to worry about D or L. Unless we're drawing, then that's when we have to worry if we have the L. But let's just go through this. So basically, when I get a big molecule like this, what I want to do is use my heterolytic function and take off the nitrogen that is added. I see this one over here has the carboxylic acid part, so I see that this came in and removed the oxygen that was here. So I'm going to remove the nitrogen from there. So now I have my two separate molecules. Now the one that's going to be first is the one lacking the oxygen. So this is going to be the first thing I write down, and this will be the second one. So remember, cut them in half. See where the nitrogen went in. Obviously this one we wouldn't disconnect from the carbon, we would disconnect it from here. And then it belongs over here because it needs a nitrogen to be an amine. Let's see, I'm going to turn this around, sort of how we did on L25, to have my nitrogen on the left, which is signifies that it is L, and we could also do the configuration, so it'd be 1, 2, 3, R, but the hydrogen is facing forward, so that makes it S, so that's how we know it's L. And then we want to look at the configuration here, well, when we're drawing, so I'll leave it like this, but let's see what we have first. So we've got 1, 2, 3, 4, 5, 6. We've got a methyl after the nitrogen, so I believe this is isoleucine. Yes, isoleucine. If this was over here, then it would be leucine, but it's not. So it's iso. So I'll put capital I, LE dash. And now I can move on to my next molecule. But first, what I want to do is, I've been having trouble drawing the isoleucines, so I see this was S configuration, and I'm going to see what configuration this is in case I have to draw it. So I've got my highest priority here, my second one over here, and then third, so it's counterclockwise, so it's S. So this isoleucine is going to be S and S. That's one thing. I didn't write notes on this, but if I did, I would probably write down, you know what, I am going to do that. So I'm just going to write isoleucine and then SS configuration. And then let's go over here and evaluate this molecule. Okay, so I have, of course I have it on the left position because these are all going to be L when we're drawing, when we're naming. And then I have one carbon in between my nitrogen, or in between this group, and my 6-member ring. So I'm going to go to my chart, and I'm going to look for something like that. I believe this is phenylalanine. So this one is actually easy to pick from because phenylalanine doesn't have an OH group, so phenylalanine, tryptophan, those are easy to find or easy to recognize. Just don't confuse the phenylalanine with tyrosine. So tyrosine looks very similar, except it has an OH group at the end, but this one doesn't, so I'm just going to write PHE, and I'm going to leave it like that. So whenever we're doing the naming ones, whenever you have a ring, it's much easier because there's not a lot of rings when we look at our amino acids, but there is a lot of chains. Okay, so we're going to do the same thing. We're going to look for that nitrogen. Okay, so I see right here that this part of the molecule only has a carbonyl as compared to this part, which means that this one connected to this first molecule. So I'm going to disconnect it, and then I'm going to move them so that I have my first one on the left and my second one on the right. So remember, the one missing the oxygen is going to be on the left, and it's when we're typing it. So let me Let me roll this around. Okay, so I see we have a long chain. I'm just gonna count all my carbons and then go to my chart. 1, 2, 3, 4, 5, 6. So I'm gonna go to my chart, and I believe this is lysine, but I'm gonna count my carbons. 1, 2, 3, 4, 5, 6. Yes. So LYS dash. And then now I can move on to my other molecule. So I'm gonna position it to where I have this group on top, and then obviously this on the left side. So I'm gonna count my carbons. I see we have an OH at the bottom. 1, 2, 3, 4. So let's see, I believe this might be serine. Let's see, 1, 2, 3, nope. Threonine maybe. 1, 2, 3, 4. Yep, it looks like threonine. THR. And I wish I would have opened up that link so I could be showing it with you guys what I'm looking at, but if you've seen L25, then you know exactly what chart I'm talking about. I just wish I could be referring to it right now. Okay, so threonine. I'm gonna start by drawing everything. And remember, I like to draw everything first and then add it at the end. You don't have to do that. I just like to do it. Threonine, nitrogen, and you know what, with the other ones, I wasn't paying attention to the chiral centers and everything, so hopefully I get them right. Lysine, let's see where lysine is. There it is. So I'm trying to draw it exactly like the picture so I kind of know where everything is. And then at the end, before I add my hydrogens and all that, I like to count my carbons and make sure that I have the right amount of carbons with everything. Okay, so now I'm going to count my carbons for threonine. I got 1, 2, 3, 4, 1, 2, 3, 4, yep. And then for lysine, I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, it looks good. And I'm going to move this over. And now this is the part that I don't like. It's not that I don't like, it's that it's just a little time consuming. Okay, so I've got my nitrogen on the left, which is where I want it. And then lastly, I want to look at this chiral center. So this should be S because it's L. So I've got my highest priority here, my second up here, and then third. It's going counterclockwise. So what I want to do is actually move things around. And the way I'm going to do that, I'm going to twist this first so that it's a bow tie. And then now I'm going to move them. So I'm just going to switch them over. And I know the chart that I provided, it has them like, it doesn't have the Fisher projections. I think the Fisher projections would be a lot more helpful on this. It's a little tricky, so if you can find a chart with Fisher projections, I would definitely use that instead. Because with this one, you kind of have to look for the chiral centers. 1, 2, 3, R. So this is S, this is R, and we're going to leave it like that. We're not going to do anything yet. We're going to evaluate this molecule first. So let's turn this thing around. And then already I see that my nitrogen is on the right side, so I'm going to move that. Okay. This one. Okay, this should be good because there's no other chiral centers, so I can be comfortable knowing that this is already good to go. And since this is the second one, this is going to be attaching to the first one, which is why whenever we have to do the naming, or it'll hopefully make sense right now. Okay, so I'm going to use my heterolytic function, and from this nitrogen, not the one at the end, the one next to all this, I'm going to grab this bond and attach it here, and then that can then go and expel water from that molecule. So that's why whenever we separate it, we'd have one less oxygen on the first one that we name because of the way we did that. If you put the wrong one, like if you were to put lys first and then threonine, then it would definitely be wrong. And then you could always go back and check your chiral centers. This might be, okay. Yeah, it's always good to check your chiral centers. I noticed that if I get the right chiral centers in the beginning, most of the time it works out that they remain. Okay, so it's gonna want me to draw phenylalanine, phenylalanine. So I've got my phenyl right here, and then I'll add my little peaks, and then my oxygens and my nitrogen. I'm gonna count my carbons right, 1, 2, 3 to the ring, so that should be good. Okay, and then I have lysine again. Okay, now I'm gonna add my oxygens. I only have 2, and then I have 2 nitrogens down here and at the very end. And then I have 1, 2, 3, 4, 5, 6, 7. I think I have too many carbon. 1, 2, 3, 4, 5, 6. I do. So I'm just gonna delete this and then change that bottom one to nitrogen. So I have 1, 2, 3, 4, 5, 6. Double check. 1, 2. Oh, I see. We're okay. I added too many up here. So this should be an oxygen. This should be a nitrogen. So now, yeah, I'm going back and checking. So I see at the first carbon, I have these 2 oxygens. At the second carbon, I have a nitrogen. And then I have 1, 2, 3, 4 carbons in between those 2 groups, this group and this one, for a total of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. So that's also a little tricky about it, but if you just take your time and really pay attention and try to match it up as best you can. Okay, so I turn this around. This is good to go because I have my nitrogen on the left, so I'm gonna leave it like this. Let me move this down a little bit so it's ready to attach. Okay, and this one, we only have 1 chiral center, so we're gonna look, oops. Okay, it's L already because it's on the left and they're facing towards me. So this is good to go. There's no other chiral centers, just like we saw on the last example. There's only 1. So I'm gonna use my hydrolytic function and I'm gonna grab this carbon and expel water. I'm gonna go then and delete water because we don't need it. Okay, so this is what we have at the end. You can always go back and check your chiral centers, but when we only have 1 and it's the L one, then it's really easy to be sure that it's right, you know? It's harder when you have 2 chiral centers, you have to make sure the last one's opposite. 1, 2, 3, 4, 5, 6 cyclic pi electrons. Threonine, so valine. Okay. At this carbon I have a nitrogen, at this one I have all this stuff. Let me change some things. Okay, and then I have threonine, let's look for that. Okay, I'm gonna have 3 oxygens, 1 nitrogen, and lastly, I'm going to double check on my carbon count. So at the first carbon, I've got 2 oxygens. At the second one, nitrogen, third one, methyl, and an oxygen for an OH group. On my valine, I have the first carbon, these two oxygens, second, my NH, I've got one by itself. No, I've got one with two methyls. I was looking at leucine. For a total of 1, 2, 3, 4, 5. Yeah. Okay, now I'm going to add my hydrogens. And now I'll evaluate the molecules and make sure that they're all facing the way that they need to be facing. So this is easy. I only have one chiral center, which is the L, so I already see on the left, and it's good, facing towards me. So perfect. If it was facing back, we would definitely have to change things around, but this one's good to go. And then I can go ahead and check this one. Okay, I'm trying to just move this. Okay. So I see they're both facing towards me, but my nitrogen is on the right. So I want to go ahead and switch that with the hydrogen. Okay. And then I want to look at this chiral center because I do have one. And we've got our first priority here, our second and a third, S. This is S. So we want this to be R. And the reason for this, if you look at the Fisher projection, I believe that this should be on the opposite side. So if I twist it around, we would see that these two are on the same side. But for the Fisher projection, I don't have it on me. Like I said, it'd be really, really good to have it because it's really beneficial and helpful. But I'm going to switch these two. Let's see if it switched the right way. Okay, so now my chiral center should be R on the bottom. Okay. 1, 2, 3, R. Okay, and then now I'm gonna move some things around. I'm gonna roll this second molecule so I can attach it. So using my heterolytic function, I'm gonna attach it there, and then I'm gonna create water, and I'm going to delete water. Let me arrange while I delete this stuff. Okay, so this should be good to go. I'm really not sure if threonine is S and R, but I will write it down. Let's see if it is. So yes. So all I write on my notebook, threonine in parentheses SR. Isoleucine is so far the only one that is SS. Again, if you have the Fisher projections, it'll be so much easier. Okay. This one we don't have to worry about that because we're just naming. All we gotta do is find where that nitrogen was connected. So I see that this one is missing its oxygen, but this one has it. So this is where it's connected. Let me remove it. And then I'll move it to the right side, and I'll move the one lacking the oxygen on the left side. Because we've already seen the mechanism and why it's lacking it, because we expelled out water. Okay, I just see a bunch of carbons, and I believe this is isoleucine. Yeah. I've got 1, 2, 3, 4, 5, 6. ILE. And I knew that right away because I've done it a lot, and I could just recognize isoleucine because at this carbon we have the methyl. If it was on this carbon, it would just be leucine. And then this one, we're gonna turn it around. And I see that we have this group at the end, so I think this is valine, but I want to double check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So this one's valine. ILE, val. Press submit and hope for the best. So remember, the one lacking oxygen, bring it to the left. The one with 2 oxygens, keep it on the right. Just so you don't get this up here mixed up. Okay, so valine, we've already established that it's 5 carbons, so 1, 2, 3, 4, 5. On the 5th one, or I guess this would be the first one. We have our oxygen groups, and then we'll have our nitrogen on the second carbon. We move this, and then we have lysine. This is the big one. Let's see. Change some things to oxygen, and then my nitrogen, and then I'll put nitrogen here, and then I'll count my carbons. I should have 6. 1, 2, 3, 4, 5, 6. Add my hydrogens. Okay, and then let me move this around. Okay. And then we want to look, and I see that these are in the wrong positions. I want my nitrogen on the left. Oops, not heterolytic. Never heterolytic. Okay, and then I don't have another chiral center, so this one's good to go. I love those with just one. Let's see. So this one I'm gonna have to move as well. Oops. I'm gonna have to move this to the side and this one to the side, and let me arrange it. And I don't believe we have any more chiral centers. Nah, we don't. We're good to go. So now orient this to where it's going to attach to this carbon. Using my heterolytic function now, I'll go ahead and do all this stuff. Let me delete my water. And I'm going to leave it like this. I don't really want to check it. I feel confident that I did my configurations right. Okay. Like I said, if you do your configurations the first time, you shouldn't have to worry about it. This is taking a while. I didn't want it to take this long. Okay. Tryptophan is a really big molecule. I hate drawing it. It's easy to recognize, but it takes a long time to draw. So it's kind of like a love-hate relationship with tryptophan. Okay, oxygens, nitrogen. I think that is it. Let me move this, and then switch to, let's see, we're doing threonine. Okay, add my oxygens, nitrogen on the bottom. So this one has 3 oxygens, nitrogen on the bottom, 1, 2, 3, 4 carbons. This has 1, 2, 3 carbons in between the 5-member ring and the carboxylic acid group. 1, 2, 3. Okay. Add my hydrogens. Okay, and now I'm going to roll this around, and I see that these are switched, but the good thing about tryptophan is that we only have one chiral center. So although it might be tedious to draw, we only have one chiral center. Okay, I'm going to have to, let me move this. I'm going to have to move all of this. So my carbon, my nitrogen, and my hydrogen. And then we want to check that chiral center. So I've got my first priority on the oxygen, second, third, R. We want it to be S, I believe, so yes, for threonine. So it's good to have that notebook that I have. Wait, we want it to be S. We want it to be R. 1, 2, 3, right there to the right. So this is good. So it is good to have that notebook because I was about to change it to S. It looks good. Again, I'm 1, 2, 3, R. Okay, I don't know why I kept thinking that that was. Okay, whatever. I'm gonna move this a little closer, and then I'm gonna use my heterolytic function and attach there, delete, arrange. And I feel confident in my configurations. So I'm gonna leave it like this. I'll move it around a little bit so you guys can see. I know sometimes it's hard to see some things. And then my cyclic pi electrons, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do not forget to count the lone pair on nitrogen. Methionine and valine. So methionine. Methionine is not too bad either. It's easy to spot because that's sulfur. Nitrogen, sulfur should be right there. And we've got 4 carbons in between, 1, 2, 3, 4. Yep, it looks about right. Valine has 5 carbons. Oops. Okay, I'm gonna add my nitrogen, add my oxygens. I should have 5 carbons, 1, 2, 3, 4, 5. Oops, did I do the wrong? Okay, there's my nitrogen. Add my hydrogens. Roll some of these around. This is the wrong way for nitrogen to be and hydrogen. Okay, that looks good. And then this one is also the wrong way. It only has 1 chiral center, just like the other one, or just like methionine. And actually, I drew my methionine on the left side, my right side, so I should fix that before I make a mistake. So with the sulfur, it goes over here, and then this one over here. That would have been bad. Okay, I'm gonna go ahead and move some things around and use my hydrolytic function and grab over here and then grab. Okay, let me just release this and delete it because it's just getting in the way. Hydrolytic, delete, arrange. And my values on the right side with the 5 carbons, and my methionine is on the left side with my sulfur. So it's missing an oxygen, so that's exactly what we want. And I'm going to submit it. I'm hoping that my stereochemistry is correct. Yeah. Oh, I'm sorry guys, I didn't want this video to be so long. I don't know how it got so long, but this is the last one. And it's going to give me the hardest one to draw, or the longest one. Okay, 6-member ring. Nitrogen. And then we have leucine. Where is leucine? Okay, let me get my oxygens. Oxygen, 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 oxygen. Nitrogen, nitrogen, nitrogen. Okay, that looks about right. 1, 2, 3 carbons in between the ring and the oxygens. And then leucine is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Let me move this and move this. Roll it around, and I see that this is the wrong position for my nitrogen and hydrogen. Let's arrange. All right, that looks good. Let me turn this over and move it down a little bit. We only had 1 chiral center on that one, so we don't have to worry about it. Leucine, we don't have another chiral center either, so all we gotta do, oh, it's already in the right orientation. So I'll move it a little bit closer. Using my hydrolytic function, I'll grab this, grab that, arrange, move this here so I can delete it. All right, and this is what we have at the end. And again, I'm confident with my stereochemistry. We have 1, 2, 3, 4, 5, 6, and I hope that I connected my, yeah, I drew my phenylalanine phenylalanine on my left side, so it should be good. Okay, so for this one, just make sure to keep your left and your right separate. I know from one of my examples I mixed it up, but try not to mix it up. If you see phenylalanine first, even if it's easier to draw leucine, draw the phenylalanine first on the left, and then draw this one on the right, so you know exactly how to connect them and you can keep some type of organization to all of this. But yeah, good luck. This is the last one. It's not too bad. And yeah, write it on your notebook. Like for isoleucine, that one for sure is SS, and threonine is SR. So if you get a naming one, if you just want to see what the chiral centers are, just write them down in a notebook or on that paper if you printed it out. But yeah, good luck, and hopefully we all pass. Bye guys.